In this video, I will cover the basics on how to export the Chameleon dataset on Cvedia. We start here with the Explore dataset page, which gives us an overview of all the available datasets on Cvedia. And we'll pick the first one in this case, Chameleon, and we'll click on Start Project. Now that opens up a new tab that shows us here the export interface for Chameleon. On the right, we'll see here all the whole slide images that are contained inside this dataset. And on the left, you'll see that we're dealing here with a bit over 400 different slides. Now, you'll see it's divided into two different subsets or parts. One is the test set and one is the training set. In our case, we're only going to use the training set, so we'll just select that one. And since I'd like to show you how to create the setup for a binary classifier, we'll also create two collections. Now, binary meaning that we'll have one collection or class that serves as the background and one that serves as the area that is affected or the metastases areas. So we'll start with creating two collections here, and I'll just rename them so they more accurately reflect their contents. So we have here healthy tissue, and then here we have one which we will call metastases. All right. Now, of course, we don't want to use affected tissue on the healthy tissue collection, so we're going to create a filter. So by clicking on filter, we specify that we only want to have images, and we pick image label in this case, only images that are normal. All right, we click on save, and we see the counter reflecting the number of healthy slides that we have available. And we'll do the same thing for metastases. So we click on this one, again we click on filter, and we'll say image label needs to equal tumor. And we'll see again the counter updating. Now, of course, we can't just export the slides as a whole. We'll need to start to generate some areas, smaller areas, that the network model is able to train on. So we'll pick here augmentations, and we add a new augmentation, and we'll use in this case random crop. Now, we select random crop, and we get here several configuration options for that. We have here first width and height, which of course indicate the size of the random crop we want to take. Now, I think that for now the default is fine, 256, which pretty much is standard, I say. So we'll leave that. And let me skip the next three options for a second and first go on to insight. Now, insight, here you pretty much specify the polygon areas that you would like to generate the crops from. So we have here three options. Either we generate crops from the tissue edges, which means lymph nodes including fat tissue, so pretty much anything that got detected by the microscope. Or we only use lymph nodes, which means only the dark purple bits of the tissue. Or we have only metastases. Now in this case we're going for healthy tissue, so I'll just select here lymph nodes. And then we are going to set the policy. The policy indicates how we are going to generate our crops from those polygons. So in our case, we're going to pick single crop per image area balanced. That means if we have a whole slide image that contains multiple polygons, we're going to treat them as one large area and only pick one of these randomly. If we pick, for example, the first one, single crop per polygon, then we could get up to 20 different images per slide, depending on the number of polygons. And of course, this can create a form of a bias towards one slide over another. So in this case, we're just going to select here, single crop per image area balanced. Okay, and if I now click on preview, you'll see all the random lymph node tissues being presented on the preview panel. Next up, we'll do the same thing for metastases. So we'll click on there and wait for it to load. All right, here you go. And then we repeat the same process. We click again on Add Augmentations, Random Crop, and we'll leave those settings to be the same, 256. We click on Insight, and in this case, we click on Metastases. And again, we set it to area balanced. We click on preview, and you'll see here the affected tissue being presented in the preview slides. Now you might notice this error here on top, N10001, that indicates that there were polygons that were too small to actually encompass one entire random crop area. Now we could solve that in several ways. We could reduce either the width and the height of the crop we want, or we can change the enclose parameter. And enclose pretty much indicates how many points of the random crop, which of course is a square, needs to be inside the polygon. Now we could reduce it to 1 and you would not have any issues, but in our case we just leave it to 4 because it's truly only a warning and doesn't really cause any changes in the on the export. So we'll just ignore that for now. Now next up we are going to define the output format. The output format specifies the fields that we want to export to your local disk. In this case there is a default, which is image, of course image 1, as you can see here, and this is the image that you're seeing right now. Now since we are producing a binary classifier, it would be very convenient if we'd have a label to indicate what image contains what. So in this case we'll just add one more field, which we can call, for example, ground. So we have a source image and a ground, and we'll set that in our case to constant integer, meaning we want to output an integer value. Now we'll click here on field override, and then you'll see here I have my 3 collections. One is base, which is pretty much the default in case you don't export any collections, so we'll just set that to 0 for now. Then healthy tissue, which is our background class, is also set to 0, and metastases we set to 1. I'll click on save, and that is now set. And if I then reload, for example, healthy tissue, you'll see that indeed the value 0 is now being output alongside as the ground. And if I click on metastases, you'll see the same thing happening, but then showing a 1, as you can see. And that pretty much is the entire setup we have to do here. Next up, we can go to the export dataset setting. Now here we'll have several options available. First we can choose the collections that we'd like to export. Now in our case we want to export healthy tissue and metastases, so we can disable base for now. And then we have here an option called iterations. Now iterations pretty much defines the number of times we want to repeat the process we've set up here, because in this case we're going to get roughly 116 images containing metastases and roughly 160 containing healthy tissue. Now of course that's not enough for training. We would like to have in the hundreds of thousands. So either you could increase the number of images on random crop, or you can tell the system to repeat the same process maybe 100 or 1,000 times, which would of course multiply this value by the number of iterations. But in this case I'll leave it to 1, but you're free to increase this to whatever value you deem necessary. Now on the dataset split, I have the option to specify how I want the dataset to be split on export. So in this case I'll just put validate to 0 and test to 40, which will give me a nice 60-40 split on the exported data. In output module I can specify which storage engine I'd like to use on the Cvedia CLI, which pretty much indicates what framework I'm using and which format I'd like to store my data. In this case we only show CSV, but in the coming days we'll add their support for TF records and for HDF5 and any other formats that people would like to see on this. Now the folder name, if empty, it uses your job ID, which you'll see right here, which might not be the best name for a folder. So in this case we'll just put there, for example, Chameleon. And that would create a Chameleon folder on the drive where I export. And yes, after this you pretty much can just copy this command line and run it on your server where you have installed the Cvedia CLI. And if you don't know how to, then you can check this out on the Cvedia user group where we explain how to install this. And if you run this command line, you'll see the export being executed and using your settings provided here to generate your training set. And after that, it's a matter of just starting your training. And with that, we conclude this video on how to prepare the Chameleon dataset.